again, math students. We're going to keep talking about triangles today, but we're going to talk about some other kind of angles that we can get when we're looking at triangles. So in a triangle, usually, everything we talked about yesterday was all about the interior angles, the three angles that are inside the triangle. You know that those add up to 180 degrees. The part that a lot of people don't think about is that we also have exterior angles of triangles. So they have all of those blue shaded exterior angles. Usually when we talk about an exterior angle of a triangle, so if I'm looking at this bottom left corner, so here's the interior angle. If I would just extend this side, this is the exterior angle that they're talking about. Now, we're only going to be worried about one exterior angle at each vertex. Realize that that one that I just drew is vertical with this one, so they would be exactly the same. So it doesn't matter which of those exterior angles I'm talking about from any vertex of a triangle, those exterior angles would be congruent, but we're only going to be worried about just one of the angles at a time when we're looking at those. Now, we've done in the last lesson another thing with this where I said, hey, I'm not going to make you cut out triangles, and I'm still not making you cut out triangles, but what they have this ruler here for is to say that they're going to extend this side of my triangle. So that really creates angle D over here. Then what they're going to do is they ripped off B and A, and they're going to bring those over here, and those three angles, A, B, and C, make 180 degrees. We did that yesterday, you know that. But here's what I want you to see right now. These two angles, angle A and angle B, are the exact same as angle D. The exterior angle from one vertex is going to be the same as the two angles that it's not touching when you add them together. It's called the sum of the remote interior angles. That's what we say in geometry. But it's going to be the same as those two angles it's not touching. That's all you really need to worry about there. And again, not something that a lot of people think about. It's not a hard thing to get your brain around, but it's something that probably is a new thing about triangles that you haven't thought about before. So in this picture, you can see what we were just talking about. This exterior angle Z, so angle Z over here, is going to be equal to X plus Y. This angle plus this angle. And by the way, this whole exterior angle thing is really just a shortcut. Instead of, and you'll see when we do some of these problems, but instead of just finding out that other interior angle and then getting the supplement to make a straight line, we're just trying to skip over a step. The study tip that's on here is that one thing that I just said, we're only going to worry about one exterior angle at each vertex. But angle X in the first example, because it's not touching the 36 and the 72, that's what it would be equal to, is if I add the 36 and the 72. So that would be 108 degrees. So that exterior angle is 108. Now again, I said this is really just a shortcut. If I would add the 36 and the 72, that got me the 108. That means that, let me call this angle N right here, 108 from these two angles plus angle N should be equal to 180. All right, so we can do this work. So that means that angle N is going to be 72 degrees. Well, then these two are supplementary, so I would do 180 minus 72. Oh, look, it gets me right back to that 108. Why bother finding that interior angle in the triangle and then finding the supplement of it if those two angles are the same as the one exterior angle? Now, in B, I couldn't just kind of, do that longer way around. I have to actually use that exterior angle theorem. That's what it's called. I would add this angle plus this angle, and it should be equal to this angle. So there's my equation. The 2a is the exterior angle. Remember, the a minus 5 is just in parentheses to say that's one angle. And then I would kind of clean that up, right? I could take that -5 with the 80 and make it a 75. Then I would solve this by getting rid of this 1a, and then I would have 2a minus A would just be 1A equals 75. So that exterior angle is not just 75. The A was 75. That means 2 times, whoops, well, that was not quite right. 2 times that, let me see if I can move this back where it's supposed to be. Sorry about that. 2 times 75 gives me 150 degrees for this. And again, if I would check this, if A is 75, 75 minus 5 is just going to be 70. So 80 plus 70 would be 150. So that exterior angle was 150 degrees. In number 5, you know the right angle is 90 degrees. So I could just say that X is going to be these two added together. So that angle is 130 degrees for that exterior angle. If you went the long way around, you could say, well, if I've got a 90 and a 40, this would have to be a 50 to make 180 degrees.
If Olivia Scheid is in the building, please come to the main office. Olivia Scheid.
Sorry about that, but let's keep on going with number 6. Again, that exterior angle, the X, would be equal to 88 plus 47. Those are the two remote, not touching, interior angles, or not adjacent, we could say. So that would be 135 degrees for the exterior angle. Number 3 is fine. Number 4 would take a little bit more work. Number 3, I would hope that you could look at this now and say, oh, well, y equals 70, right? It's just 40 plus 30. That's easy. Number 4, we're going to need an equation here. This exterior angle, 4n minus 20, would be equal to the two interior angles that aren't touching it. So 2n plus 20 plus another n. So when I clean that up, 2n plus n would be 3n plus 20. So let's get rid of my 3n. N minus 20 equals 20. And then I would have to add the 20. So the n would be 40. Now, here's the problem. Some people want to stop right there. Remember, we have to find the exterior angle. That's what they were looking for. So this angle I need to know. If n is 40, then I would have 4 times 40, which is really going to be 160 minus 20. 160 minus 20 would be 140 degrees for this angle. If I would check the other angles, this is 40 because that's just an n. 2 times 40 would be 80 plus 20 is 100, and 40 plus 100 is 140, just like we have for the exterior angle. This is an older problem. This is an isosceles triangle. These are all interior angles. We've done this already. This is no big deal. So I could write an equation and say 2x plus 110 equals 180. So 2x equals 70, and x would be 35. So each of these angles in the bottom of the triangle would be 35 degrees. All right, we know names for triangles, so we can use that when we're looking at these pictures. The pictures are also in order for what we need. I wanted to find the Q in the acute triangle. So we already know that I've got a 70 and a 33. These are all interior angles. That means that these two together would be 103. So if I had 180 for the whole triangle minus 103, that would give me 77 degrees. The R in the right triangle, again, it's important to know that that is a right angle. So this is 90 plus the 31 that's there is 121. And 180 minus 121 would be 59 for that angle. In an equilateral triangle, they did say A for all three of them, but I'm guessing that a lot of you know this anyway. I would have 1A plus 1A plus 1A is 3A equals 180. So A would be 60. Each of those angles will be 60 degrees. 60 plus 60 plus 60 is 180. In the isosceles triangle, so we've got that 68-degree angle on the top that we would want to use in our equation, I guess. So I would have 2C plus 68 equals 180. So we would get rid of the 68, which would give me 112. And then divide by 2. That would be 56. Each of those angles would both be 56 degrees. And number 5, I have variables in all three angles. So I would, let's do that over here, I would have 5D plus 4D plus 1D equals 180, which would be 10D so D is going to be 18. So that means that one angle, this angle right here, is going to be 18. 18 times 4 is 72 degrees, and 18 times 5 is actually 90 degrees. This triangle does not look accurate. It's not drawn to look like you've got a 90-degree angle there. And I apologize for that, but sometimes they purposely draw triangles so that they don't look like the angles are the right size. They don't want you just taking a protractor and measuring. Number 6, we've got a story problem. The second angle in a triangle is half as large as the first. The third angle is 3 times as large as the second. So let's find those angle measures. All right, this one, I have 2 different ways to do this, but it's kind of up to you how you want to interpret this. It says the second angle in a triangle is half as large as the first. If I call the first angle just x, then the second angle is going to be 1/2 x. However, if I say that the first angle, this is kind of my trick on this, if I said that the first angle was, let's say, 2x, then the second angle is half as large. Well, now that's just x, and I don't have to have a fraction. The third angle is 3 times as large as the second angle. So now 3 times the x is just going to be 3x. I want to find those angle measures. This is now easy to do, right? I would have 2x plus 3x is 180. And that would be 6x. So x is 30. I want to find all of the angles though. So that means that this angle is 30 degrees, and this one would be 60 degrees, and this one would be 90 degrees. It does say to draw a possible picture for that. I'm sorry, my marker is a little bit too big to fit in that tiny little space. And for this last problem, I love these kind of problems where it's kind of a multi-step and you have to keep getting one answer to be able to find the next answer. So to find angle 1, I know the 85 degrees and the 40 degrees in that first triangle. That would be a total of 125. So I could take 180 minus 125 from adding these two together, and that would give me 55 degrees for this angle. Well, angle 1 and angle 2 are actually vertical angles, so they'd be the same. So if angle 1 is 55, then angle 2 is also 55. And now I've got, in my second triangle, 2 angles that are each 55 degrees. That's 110 degrees. That would leave 70 degrees right there. Here's the last problem. Getting a little bit more difficult. I know that the exterior angle at E is 120 degrees. And I know that an exterior angle would be equal to these two interior angles that it's not touching. So I would have 5x plus 2 plus 4x minus 8 equals 120. So that's going to be 9x minus 6. And 126 divided by 9 is going to be 14. But that's not what my question is. The question is for you to find angle EAT, which is EAT, this angle up here, and then angle ATE, so A to T to E. So I really have to find those two angles. If the x is 14, then I would have 5 times 14, which would be 70, plus 2 is going to be 72 degrees. And 4 times 14 would be 56, minus 8 would be 48 degrees. And if I would add 72 plus 48, it does give me that 120 degrees. Now, today's worksheet, and it's from a book. I just didn't change the numbering. That's why it starts at number 10 instead of number 1. But it's just a worksheet. The answer key is in Schoology. And then when you finish that up, make sure that you take the learning check and let me know if you need any help.